Welcome back. If you're just joining us or don't feel like following along, a link to download the code in this video is in the description below. Today we're going to be breaking our big spawner method up into smaller, more specific methods. While it's really cool to have a method that does so much in one package, it also makes it a bit unwieldy and a little bit confusing to use. We'll be splitting up our spawner method into 6 separate methods today. The first set of methods will deal with spawners with fixed delay, and the second one will deal with spawners with a random delay. We'll first create a method called spawnIndy. We'll give it the arguments toSpawn, spawn position, spawn delay, and spawn amount. First, we'll create a loop to control how many times the code is run. In our loop, we'll create a yield, and within it, create a scene tree timer with a countdown equal to our spawn delay. The yield will end as soon as the timer emits the timeout signal. Once our timer expires, we declare a variable called newSpawn and make it equal to an instance of what we want to spawn. We then add that instance to the tree as a child of our spawner node. And finally, we set our instance's global position to the spawn position. Okay, that wasn't so bad, was it? Let's keep going. Next up is spawning a fixed array of objects. Create a method called spawnFixedArray and give it the arguments toSpawn, spawn position, spawn delay, and spawn amount. Just like the last method, we'll start with a for loop to run the code as many times as the spawn amount. And within that loop, we'll create another loop, this time to iterate through our array of objects to spawn. Now continue just like the last method. Create a yield with a timer, declare a variable equal to an instance of what you're spawning, add that instance as a child of the spawner node, and set its global position to the spawn position. But take note that since we're iterating through an array of objects, we need to use our loop's keyword rather than our toSpawn argument when we create our instance variable. Alright, we're going to start getting a little crazy here. The next method is going to randomize an array before spawning it, with the option of randomizing the array for every complete array that is spawned. You create a new method called spawnRandArray and give it the arguments toSpawn, spawn position, spawn delay, spawn amount, and random per spawn, which will be a boolean. First, we check if random per spawn is true. If so, we then loop through the spawn amount. Inside this loop, we'll randomize Godot's built-in random number generator seed and shuffle our toSpawn array. The reason why we randomize Godot's built-in random number generator seed is because it is the generator responsible for randomness when shuffling array. Once the array is shuffled, we can then loop through our toSpawn array and spawn each object just like the previous method. Now let's deal with the else to this if statement. So if random per spawn is false, we'll randomize the seed and shuffle our array before we enter any of our loops. Once we have everything shuffled, we then continue as before, creating a for loop to go through our spawn amount, and within that, one to loop through the array we wish to spawn. Congratulations, everybody, we're halfway there. Now, let's make some methods that deal with random spawn delays. Before we do, I want to create a small method that will help reduce the tedium a little bit, and we'll create a method that generates just some random times for us. Okay, we'll scroll down and create a method called random time. Give it the arguments minimum time and maximum time. First, we'll randomize our random number generator's seed. We do this because it's responsible for random range generation, which is what we're using here. Next, declare a variable called randTime and use our random number generator to make it equal to a random float between our minimum time and maximum time. And lastly, return the variable rand time. Now that's done, let's continue. Next, we'll create a method that spawns individual objects with random spawn delays. We create a method called spawnRDelayIndy. Give it the arguments toSpawn, spawn position, minimum time, maximum time, spawn amount, and random time per spawn, which will be a boolean. And this argument is going to control whether or not we'll generate a different random spawn delay for each instance we spawn, or if we'll generate a single spawn delay to use for multiple instances. First, we'll check if our rand time per spawn is true. If so, we'll create a loop through our spawn amount. Within that loop, we will create a timer just like before, but this time we use our random time method to generate a spawn delay for our timer. Once the timer expires, we continue just like we would before. Now if rand time per spawn is false, we'll first declare the variable rand time and then use our random time generator to give it a value. We'll then input that value when we create our timer within our spawn loop. Alright, Owen was a piece of cake, right? Real easy. Let's keep going. We only have 2 more methods left. Okay, the next method is our fixed array spawner. Let's go ahead and add some random delays in there. Okay, we'll create a method called rDelay fixed array. We'll give it the arguments toSpawn, spawn position, minimum time, maximum time, spawn amount, and random time per spawn. Just like the last script, we'll first check to see if rand time per spawn is true. Then we'll loop through our spawn amount, and within that we start our spawn loop and create a scene tree timer using our random time method. We finish this block out the way we have been when we want to spawn objects in an array. And now should random time be false, we'll generate a random time before we enter our spawn amount loop and continue just like we did before. Alright, let's start on our final method. It spawns a random delay and it randomizes the array. This one takes arguments toSpawn, spawn position, minimum time, maximum time, spawn amount, random order per spawn, and random time per spawn. We start by checking if random order per spawn is true. Remember, this controls whether the array will be randomized each time it is looped through. Next, we'll ask if random time per spawn is true. Now we're ready to enter our spawn amount loop. We'll randomize Godot's built-in seed and shuffle our spawn array. Then we enter our spawn loop and create a timer using our random time generator, and the spawning logic continues just like before. Now should random time per spawn be false, we'll generate our spawn time before entering our loops and use that time in our timer. The rest of the code should match the previous block. Okay, we're almost there, people. Should random order per spawn be false, we'll first randomize Godot's seed and shuffle our spawn array before entering any loops. We then check if random time per spawn is true, and we'll create our spawn amount loop and then our spawning loop with our timer using our random time method. And finally, our last block, should random time per spawn be false, we'll generate a random time before our loops and use it in our timer. And that's it. You all made it. I'm amazed. I'm impressed. You are wonderful. If you're still with us, thank you. Hope you found it useful. There is one more thing we need to do, and this will be dealt with in a future video, but we're going to go ahead and give our script a class name and call it Spawner2D. When we've done this, we'll be able to create an instance of it in other scripts and use it like we used we'll be able to use its methods like we used the random number generator in this script. So stay tuned. Don't forget to like and subscribe, and I'll be seeing you next time.